Hello, exceptional students of Mrs. Winnie's. So we're on to lesson 2.3, which is subtracting rational numbers. And honestly, subtracting rational numbers is just like subtracting integers. You rewrite them as addition problems and then solve them. So let's get started with example number 1, where we're going to subtract negative 4 and 1/7, subtract negative 6/7. So before you panic and look at that and go, oh my gosh, that's so hard. Remember that they're the same denominator, so it's not that difficult, and that it looks big and ugly, but just break it down, it won't be that bad. So we're going to take this and we're going to rewrite it as an addition problem. So the first number stays the same. So it's negative 4 and 1/7. We change the subtraction to addition. And we change the negative 6/7 to be positive 6/7. So we rewrite it as adding the opposite. Add the opposite. So our next step now is, are the signs the same or different? So different signs. So we need to subtract. So we're going to take the larger absolute value, which is 4 and 1/7, and we're going to subtract from that negative 6/7. Notice how I line up my rational, or my fractions. So there's one on top of the other. So what I'm going to do is, can I take 6/7 away from 1/7? And I cannot. So I need to borrow. So I'm going to take 1 whole away from the 4 and change that to 3. Then I'm going to add 7/7. So if I add 7, I will end up with 8/7. So see how I took 1 whole one, which is 7/7. So 7/7 plus 1/7 gives me 8/7. Now I can subtract 6 from the 8, so I get 2/7. And I so 3 subtract nothing, because there's no whole number there, is 3. And because I had more negatives than positives, I end up with negative 3 and 2/7. Okay, on to subtracting rational numbers with fractions. So again, I'm going to rewrite this as 12 and 8/10, adding a negative 21 and 6/10. So signs are different. So different signs. Actually, let's add the opposite here. Add the opposite. So different signs. So we're going to subtract. The larger absolute value is 21 and is 6/10. I'm going to subtract from that 12 and 8/10. I'm going to have to borrow. So 6 from 16 is 8. I lined up the decimal points, so decimal points just gets pulled down there. I have to borrow again, so I have 10. So I end up with 8 and 8/10, and my answer is negative because I had more negatives than positives to begin with. Okay, our third example is finding the distance between numbers on a number line. This is a range question. We've done this a billion times. I told you anytime that we get subtraction problems, they like to make it a range problem. So we take, since it's range, we're going to, range is the larger number, subtract the smaller number. So the larger number here, in this case, is 2 and 1/3, and we're going to subtract a negative 2 and 2/3. We're going to rewrite it. Remember, add the opposite. This is the step you still must write. So it becomes 2 and 1/3 plus 2 and 2/3. Because the subtraction becomes addition. The opposite of negative 2 and 2/3 is positive 2 and 2/3. So I add the whole numbers, I get a 4. I add 1/3 to 2/3, I get 3/3. So I have 4 and 3/3, which is just 5. Not so bad. Okay, real life application. In the water, the bottom of a boat is 2 1/10 feet below the surface, and the top of the boat is 8 7/10 above it. Towed on a trailer, the bottom of the boat is 1 3/10 feet above the ground. Can the boat and trailer pass under the bridge? Okay, I'm going to draw a picture. You know I like to draw pictures. So I have a boat on a trailer. Here's my boat. And I know that the water line, if the boat was in the water, the boat is 2 1/10 feet below the surface. So I know from here to the bottom of the boat is 2 1/10. The boat from the top of the boat, from the water line to the top of the boat, is 8 7/10. I know this isn't really drawn to scale. And towed on the trailer, the bottom of the boat is 1 3/10. So I have to know whether all of this is less than the 11 feet and 8 inches. I'm going to add up all of those, and I'm going to end up 3 plus 7/10, or 3/10 plus 7/10 is 1, plus another is 11. So carry the 1, 8, 9, 10, 11, 12. So this is 12 1/10 feet. Will that fit under that bridge? And no, it won't. You could go through the trouble of converting everything, but why bother? 11 feet is clearly less than 12 feet, so it's not going to work. Thanks for watching.